Hello, this is Mrs. Hyman. State the domain and range of each relation. Then determine whether each relation is a function. If it is a function, determine if it is one-to-one, onto, both, or neither. The first relation, we just have a set of points listed, and so we need to identify the domain and the range first. Well, the domain is the x values. Okay, the domain is the x's. So when we take a look at the set of points, the x's are the first number in our ordered pair. So we have 3, -4, and so on. So we're going to put that in little set notation, little brackets. We're going to list those values, 3, -4. Next we have -1, then 2, and the last x value or domain value is 1. Okay, the range then will be the y values, and the y values are those second values in our ordered pair. So first we have -8, next we have 6, the next value is -6, then we have 4, and the last value is 0. So we have the domain and range listed. Well, now we have to determine whether or not we have a function. Well, for a function, it means that every element in the domain, so that's each of the x's, can have only one pair in the range. So if we take a look, the 3 is paired with -8 only from our ordered pair right here. 3 doesn't get paired with any other values. The same with -4, it has one pair. -1 has one pair with 2 and 1. So it is a function. Because each element of the domain has only one pair in the range. So since it is a function, we need to decide if it is one-to-one. Well, a one-to-one function means that each element of the range would be paired with one element in the domain. And again, if we look at either the ordered pairs or our domain and range as we list them, we can see that each y value has only one x value that it's paired with. So yes, it is one-to-one. Okay, now the next is onto. The function is onto if each element of the range has at least a pair in the domain. And since we already determined that it is one-to-one, saying that each element of the range does have one pair in the range, each element in the range has one pair in the domain, so it is also onto. The next relation is given to us, again, a set of points, but they're all graphed and they're labeled as well. So to start with our domain and range, to list those, our domain values again are the x's, and so we'll take those x values right from the points. So -2, and moving across the graph, I see we have 0 and 0 again. We only need to list that one time. And then our next point as we move across, we have a 1. And the last one here is 2. So those are all the x values or all the members of the domain. Next we'll list the elements of the range. And those are the y values again. So we'll go through our points again. We have a 2. Next we have 3. And we have down here a -4. We have a 2 again, but we don't need to list it twice. We already have it from here. And then I see 3 again, but again we've already listed it once. So that is our range, 2, 3, and -4. But we have to decide if it is a function now. And again, a function, for every element in the domain, it has only one pair in the range. So we talked about how some things are repeated. Like right here, this point 0, 3, and this point down here, 0, negative 4. The element 0 in the domain is paired with two values. It's paired with a 3, and it's paired with a negative 4. So that means that this one is not a function.